Okay, dear students, let us take one example now. Let us do this question number one. Now, that is the preposition is prove that 3 raised to power n plus 1 is divisible by it is divisible by 2 for all n greater than and equal to 0. Now the problem is you cannot prove it by taking assuming n is equal to 1, 2, 3, 4 up to 100 or up to 1000. You can't keep on doing like that. So you have to have a principle here now. So what we do is let us first of all try to do it for n is equal to 1. So I am going to call it step number 1. I say that for n is equal to 1, let us see if it is coming out to be true or not. So p of 1 is 3 raised to power 1 plus 1. This is coming out to be 4. And yes, it is divisible by 2. That is absolutely correct. So we will say that so the proposition is correct for n is equal to 1. Now, we are moving to step number 2. Now, step number 2 is an assumption. What is this assumption? We will say that for n is equal to k, we just assume that it is right. Now, we don't know whether it will be right or not. We just assume that 3 raised to power k plus 1 is equal to or it is divisible by 2. We just assume it. Now, if something is divisible by 2, you can write it as 2x something. We can write like 2x, like x is some other number, and because it is divisible by 2, you can write it as 2x. So I have written it as 2x. Now, this is clearly an assumption. Clearly an assumption. But now, what I am going to do in step number 3? In step number 3, I am going to take n is equal to k plus 1. So for p is equal to k plus 1, we are going to have 3 raised to power k plus 1 plus 1. Now this, we have to take 2 common out of it to prove it that it is divisible by 2. Let us see how are we going to do this. So what we do is we divide this thing. So it can be written as 3 multiplied by 3 raised to power k plus 1. Yes, 3 multiplied by 3 raised to power k plus 1. And now I am going to take this value 3k plus 1 from here. I will say that 3k can be taken as 2x minus 1. I am going to substitute this equation here. 2x minus 1 plus 1. Now multiply 3 to the 6 minus 3 plus 1. So it is coming out to be 6x minus 2. And yes, now we can take 2 common out of this. So this thing can be written as, when you take 2 common, it come out to be 3x minus 1. So I can say that this p of k plus 1 is coming out to be this twice of 3x minus 1. 3x minus 1. And hence, yes, this is also divisible by 2. This is also divisible by 2. So what can I write now? I would be writing a statement here. Now, what is that statement? I will say that because p into k plus 1 is true, if p of k is assumed to be true. To be true, or the statement is just right. So, if p of 1 is true, the proposition should be true for all consecutive integers. Do you get my point? This is how we do it. We have now proved that it is correct for p of 1. It is correct for n is equal to 1. Now, if it is correct for pk, we have proved that pk1 is correct. So if it is correct